Hello, this is a presentation on server-side technologies with an introduction to the PHP scripting language. My name is Trevor Johns. This talk was originally held on February 14th, 2008 at the University of Southern California as part of the USC Google Workshop Series. This talk in particular is presented by USC Epsilon Pi Epsilon, the Computer Science Honor Society. This is a retake of the original February 14th, 2008 talk because unfortunately we had technical difficulties with the video that night. Unfortunately, this means that we don't have any of the audience questions on tape, but if you do have any questions about this presentation, you're welcome to email me at the email address on screen. Alright, let's get started. So this talk takes about 1 hour. During this presentation, we're going to cover server-side scripting in general, move into an introduction to the PHP scripting language, and then go over a demo where we create a sample PHP application. So during this talk, I'm going to assume that you already know the basics of working with Unix. You have some experience with an object-oriented programming language. C++ or Java would be best since you'll see PHP is very similar to those languages, but if you have experience with some other language, that's alright too. I also assume that you have experience with basic data structures, and so example, you know what an array and a hash is. And I'm also assuming that you know what HTML is, since PHP is often used to create HTML pages, and so that's also what we're going to be doing during our sample application. So this, just to be clear, this is an introductory talk, so we're not going to be covering any advanced topics. You're certainly welcome to email me with any advanced questions you have, and we had some people ask some questions during the actual talk as well. But if you're already familiar with PHP, you're probably not going to get very much new out of this talk. So as far as ground rules, obviously you can't stop me if you have any questions since this is a retape, but you're encouraged to follow along during the demonstrations, and of course to have fun. So server-side scripting versus client-side scripting. Client-side scripting is things like almost always is JavaScript, and they're executed by the browser. So on screen we have some sample JavaScript code, and as you can see it's sent along with the HTML to the user's browser, and the browser executes it as it goes and renders the HTML. So in this case, when it loads, it'll go and display the answer as 42. However, if they have JavaScript disabled, they're not going to see this. In this case, we've put up a nice little error message that will inform the user of this, but in some cases this can be more drastic. Also, since everything's executed on the client's computer, whatever resources the script is going to be accessing is also accessible to the user. So, server-side scripting, on the other hand, is slightly different. Here we have a script written in PHP, and the very first thing it does is it computes the result of adding 40 plus 2, and then it outputs that, and just like before, it'll say the result is 42. However, this is all executed on the server. As soon as the client loads the page, they're going to see something quite different. They're not going to see any of the code at all. All they're going to see is the HTML that the browser is supposed to render. And so this has a number of benefits which we'll go over in a moment. So this is the basic flow of a server-side request. In green, you see what a normal request would look like, so just for a static HTML page, possibly including some client-side JavaScript. So the client's web browser goes and makes a request to the web server. The web server retrieves the file from disk corresponding to that request and returns it back to the client's web browser. However, if the client requests a page that uses a server-side script, such as PHP on the last slide, the web server will detect that, pull up the page corresponding to that request, and forward it towards a server-side interpreter. This interpreter goes and reads through the file, figures out what resources need to be accessed, which is most commonly a database, though it could be other files on the hard drive or network resources. And then when it's done, it'll go and output generated HTML, which is then forwarded onto the client's web browser. So server-side scripts, just like client-side scripts, are able to generate dynamic content. However, unlike client-side scripts, they can't modify the page after loading. So you can't go and do this to create AJAX pages, for example. Server-side scripts are able to access sensitive resources such as databases. So for example, if you had some sort of billing application and you did it entirely in JavaScript, there's always the risk that the user just goes to view source, looks at the JavaScript and figures out where the database corresponding to your data is, and then can go and tweak it just as if they were the script. So oftentimes we want to go and give the script elevated permissions above what the user is able to do on their own, and so server-side scripting allows us to do that. And so that goes into the next point, which is that users aren't able to view the code and they're not able to tamper with the code. There's no browser support needed since everything that's forwarded along to the user is just plain ordinary HTML. On the other hand, this requires that we install special software on the server. So the server needs to know how to go and execute the script and access any resources that are required. There's a lot of server-side languages to choose from, whereas with client-side scripting, normally it's just JavaScript. So if you have a particular preference, you can, as far as languages go, there's a good chance you'll be able to use it. Server-side scripting tends to be fast since everything is executed on the server, and in some cases it can even be precompiled. However, this also means that the code is less scalable since every single request is going to require executing this code on the server, whereas with client-side scripting, the user's browser is the one that's executing it, so it gets distributed in a way. There's also the possibility that using server-side scripts can pose a security risk. For example, if you're doing file system operations that depend on user input to look up the file name, the user might be able to go and manipulate the file that your script thinks is opening and open some other sensitive file on the hard drive. Or there's other cases too where, in the case of database access, if there's fields that aren't escaped, they go and can access parts of the database that they're not supposed to be able to access. And this can be mitigated through properly escaping user input and making sure that your server-side software is up to date with whatever the latest releases are. However, this is still something that you need to keep in mind. And even though if you try and keep everything up to date, there's always the small chance that somebody discovers some vulnerability that hasn't been patched yet. So, as I mentioned, there's plenty of languages to choose from. In this talk, we're going to be going over PHP. However, there's plenty of others. Server-side include has been included in the Apache web browser for, well, forever now. ASP is Microsoft's technology for server-side scripting. JSP is Java's implementation. Perl has been around for quite a while. Cold Fusion is Macromedia's server-side scripting product. Python and Ruby are both languages that are normally used for scripting desktop applications, but they can also be integrated into a web browser to go and implement server-side scripting as well. You can actually even use output from a C or C++ program or any other language through the CGI Common Gateway Interface mechanism. However, this you don't see this very much as often because this actually does pose a very serious security risk if you're not very careful in designing your program. So usually CGI is normally only used to go and invoke PHP or Python or Ruby or one of these other ones, and even then a lot of times there's other alternatives that are preferred, such as creating an Apache module or using fast CGI. So PHP itself was originally created in 1994 as personal homepage tools, and it was designed to go and replace a set of Perl scripts that the author was using on his own website. This was version 1. There was also a version 2, which was a slight improvement to this. In 1997, a group of developers completely rewrote it and renamed it to PHP Hypertext Processor, which is a recursive acronym, and this is PHP 3. This is really the first version of PHP as we know today. PHP has since gone through 2 other major iterations, version 4 and version 5. There's a number of changes, but the biggest one is the addition of object-oriented programming support, which wasn't available in PHP 3. So PHP is both a scripting language and a framework for developing websites. So as a scripting language, it has its own unique syntax. And as a framework for developing websites, it includes a number of library calls and functions that are useful for web developers, and this is partly why it's become so popular. It's just well suited to creating HTML. PHP is loosely typed, so that means that variables don't have to be specifically defined as an integer or a string, for example. And as you go and perform operations on those variables, the language will automatically cast things back and forth as needed. It's also a garbage collected language, so you don't have to worry about explicit memory management as you would have to in C or C++. PHP is an object-oriented language. It has full object-oriented support in PHP 5, slightly less in PHP 4, so if you're using PHP 4, most of the times people avoid using the OO support. And PHP 3, as I mentioned in the previous slide, doesn't have any object-oriented support whatsoever. And it's actually able to output more than HTML. So as you see online, when people go and generate dynamic PDFs or dynamic images, a PHP script is one way to go and do this. You do it just the way as you would in an HTML page, but instead of outputting HTML, you output the data that you want to the user's web browser to render. There's also a number of plugins or libraries you can get that go and actually do PDF manipulations for you, so that way you don't have to go and work with the raw data stream yourself. If you do this, just be sure to set the content type header so that the user's web browser doesn't try and interpret it as HTML. If you don't specify a content type header, the default is always to use an HTML content type, so just keep that in mind. Traditionally, people go and start out and write their PHP scripts as just the HTML they want to be rendered, and then they'll go and replace bits and pieces with the PHP code as needed to go and give it dynamic properties. Some people go and also use a model view controller framework to go and actually completely abstract the view code from their application logic. There's a number of these such as KickPHP and Zen Framework out there. If you don't use one of these, avoid the temptation to go and leave code scattered all around your HTML files. Try and put as much of it near the top of the file or in completely separate files as possible, just to go and maintain readability and to ease development later on. So we're going to go ahead and create our first PHP script. So very briefly, this is just something that goes and says hello world, then outputs the line chunky bacon 3 times. So the very first line, or the very first 5 lines, are just plain ordinary HTML. There is a left angle bracket question mark PHP, which is the way to go and tell the server-side interpreter that you're going to begin writing PHP code. There's a comment. Comments are just like in C or C++. We'll see that in just a minute here. We go and print out a h1 tag and then say hello world. We set a variable to 3, and then we have a while loop that goes and outputs our line 3 times, and each time in that while loop it decrements that counter. We have the question mark right angle bracket, which tells the web browser's interpreter that we are done with PHP code, and then we have some more just plain HTML. So just to go and show you this in action, the very first thing I'm going to go and do is connect to my account at USC. And in my public HTML directory, I'm going to go ahead and create a brand new folder just called PHP to go and hold everything from this talk. And I'm going to go ahead and create a brand new file just to go and show that PHP is working called test.php. If I open this up, and if I type, again, left angle bracket PHP, and I always close with a right angle bracket, or a question mark and a right angle bracket, and then I say PHP info, and save. I guess upload it to the server. And if I go to my website, oops, this is my USC website, so oh, there's a typo here. You can see that PHP outputs quite a bit of debugging information. This is what the PHP info call does. Most of this you're not going to be interested in as a developer. Mostly just is a good way to go and check and make sure that PHP is working. Though there is some useful stuff in here. You can go and see what PHP extensions are loaded, as well as what some of the default variables are, the constants, and see what information the web server is passing to PHP. All of this is available to you within your PHP script. So now that we've verified that PHP is working, we're going to go ahead and create a brand new file called hello.php. In this case, we're just going to go ahead and start off with some basic HTML. So let me copy this over for convenience. And we're going to end the HTML down here. So this is just a normal HTML page. It has the title My First Script and nothing inside of it. So if I save that and open it up, you can see that it's empty. If I view the source, if you're able to read that on the video, there we go. If we view the source, you can see that it's exactly what we typed in before, and this is because there's no custom PHP script to go and modify it. So let's go ahead and change that. We're going to go ahead and start a block of PHP code just like we did before with the left angle bracket question mark PHP and then the closing bracket there. So this is just the code that was in the slide on the previous page. We're going to copy that right in, save it, open it up in the web browser and reload. And as you can see, it output hello world and chunky bacon 3 times, just like we expected. And if we view the source, here is the code that was dynamically generated by our PHP script. You'll notice once again that the client's web browser does not get access to any of the code in the original source file. All this output is just plain ordinary HTML. There's no special software required. There's no, you don't have to rely on the users having JavaScript enabled. It just works. So let's go back to the slides. So this is just to go and recap what we just saw. Nothing really here that you didn't see when we were back on the desktop. So as far as some of the basics using PHP, variables always start with a $sign. So you saw that with the $sign count equals 3, and then we were able to do $sign count minus minus to decrement it just like we would in C or C++ or Java. You can also do $sign count plus plus or anything like that. Again, it's a dynamically typed language, so there's no need to explicitly say that, in this case, x is an integer or y is a string. It's able to go and determine that automatically from the context, and likewise z is going to automatically become a float. You can go and add them together and assign them to a new variable like we're doing with moof there, which is just x plus z. Moof will then automatically become a float because we're adding the two. The plus operator, unlike JavaScript, or unlike Java, is not concatenation. Concatenation is the dot operator, period. So for $y, we're saying hello world, space, and then 42. Likewise, you can go and assign variables to themselves. So x will be 42, 42. Again, notice that since dot is concatenation, we're actually going and turning 42 into a string, and then sticking the two strings together, and PHP is able to go and do that automatically. Keep in mind that x, though, is actually stored internally as an integer, so it's actually performing a cast at the very last moment there to make that possible. All lines in PHP need to end with a semicolon, just like in C, C++, or JavaScript. You can go and have lines or code that spans multiple lines, and that's perfectly acceptable just as long as at the very end of your line you put that semicolon there. Comments work pretty much the same way they do in C++. So 2 forward slashes is a single line comment, slash asterisk, and then an asterisk slash creates a multi-line comment. PHP also supports using the hash character as a single line comment, so you're able to choose whichever one you like. When you want to go and output information to the web browser, you can use the print function. Print is a special case. It actually doesn't need parentheses, whereas everywhere else in the language you do. So here we say there are 42 opossums. Just for convenience for the first one and to demonstrate, I left the parentheses out. Everywhere else I put the parentheses in. It'll work exactly the same. If you do leave the parentheses out, just be sure to keep an eye on order of operations and make sure you don't do anything that will confuse the interpreter. And then as you can see in the second case, I am including a variable within the string that'll go and get expanded as it runs it. So we'll actually see there are 42 opossums, even though the code says there are $V opossums, because we've set $V to 42. The third line shows that you can also go and use operators within the arguments to go and create new strings, so all three strings there are exactly equivalent. At the very bottom, you can see that there's a line that I said does not work, and the only difference is that I used single apostrophes instead, or single quotes instead of double quotes. And the reason why that is because of string of variable expansion. And actually, there's an error on the slide. Let me fix that very briefly here. There we go. Yes. So double quotes will expand whatever your variables are within them, whereas single quotes do not. And so basically, you'll normally want to use double quotes, and then single quotes if for some reason you're concerned about. Perhaps you want to go and include something that has a lot of dollar signs, or you want to be absolutely sure that there's no variable expansion if you're worried about the user slipping something in or something like that. Likewise, if you're in a single quote, \n or any of the other escape characters don't work, though you are able to use / single quote to go and to output a single quote if you need. And likewise, in double quotes, / double quote outputs a double quote rather than entering your string. There's a number of string manipulation functions. I've listed a couple useful ones here. String length, for example, outputs the length of a string. String position is used to go and find the location of a substring within a string. strIPOS is in case insensitive searching. strCMP, that's also a typo. Let me fix that as well. strCMP is for comparison. There's also an strICMP for case insensitive comparison. There's tokenization functions. You can convert between lowercase and uppercase. Remove white space with the trim function. Word wrap will will go and wrap after a specified number of characters if you're worried about exceeding a certain length. HTML entities will go and escape any characters that might cause problems with HTML output. So for example, if it's a text field and the user might enter a left and right angle bracket, if that's just output directly to the web browser, it'll interpret those HTML tags. And if you don't want that, HTML entities will go and convert them to their escaped equivalent, &LT and &GT. And add slashes is used to go and escape things that will cause problems with SQL or shell scripts. Normally this is specifically for SQL. I don't remember offhand if there's a separate function for escaping output to the shell. If you are worried, if you want to check that, actually, there's a website, php.net/strings, which will go and list all of the string manipulation functions available to you within PHP. So as far as arrays go, arrays are created using the array function, and they get stored into a variable just like anything else. Here we're creating an array with the elements 1, 2, 3, 4, and 5. Arrays use a zero-based index, so if we say print $a and then in square brackets the number 2, for this example that will output the integer 3 because that is the third element in the array. Again, it's zero-based, so 0, 1, 2. To append an object to the array, we just put a set of angle brackets with nothing inside of them, so $a empty, or not angle brackets, square brackets, $a empty square brackets equals 6. We'll put 6 at the end of that array. We can also go and address individual elements in the array for modifying stuff. So if we were to say $a 0 equals 10, then we would replace 1 in our array with the number 10. Right? PHP also supports custom key value pairs. This is basically a hash. It's still considered an array as far as PHP is concerned, so we use the exact same syntax as far as the array function and addressing stuff. The only difference is we use the right double arrow to go and specify our key value pairs. So here we've created a hash where foo maps onto bar, and the number 42 maps onto the Boolean to Boolean true. And so if we were to say print $b foo, that'll output bar. And if we tell it to print $b42, that'll output true. You can use the unset function to go and remove a value from an array. So if you were to say unset $B42, that will just remove 42 from the array. You can also use it to erase entire variables if you don't use the square brackets. So if we were to say unset B, that would obliterate the entire array, or that would work for any other variable as well. If you want to go and check what's inside of an array, since you normally don't have access to a debugger, the easiest way to do it is to print it out. However, if you use the print function we've seen on previous slides, what PHP does is it goes and concatenates every value within that array, and we don't really want to do that. So we use the var_dump function to go and pretty print it, basically. It works exactly the same as print, but just makes it look really nice. So it's your friend when you're debugging stuff. You normally don't want to use it, though, when you're displaying stuff to the user, since even though it's pretty printed, it's still, it still could look much better if you were to go and put it into a table or something like that. Flow control statements work exactly the same as they do in C, C++, or Java. So there's if statements, while loops, for loops, switch statements. All the comparison operators are present as well. Less than, greater than, double equals is comparison. Or equality rather. There's also something unique, the triple equal sign, which is used to go and make sure that two variables have the same type. This is just because, again, PHP is a loosely typed language. So, for example, if we have the string 2, containing the number 2, and then we have the integer 2, if we do double equals to compare those two, it'll say yes, they're equal, but if we do triple equals, it will say no, they're not, because even though they both represent 2, one is a string and one is an integer. PHP also has one other useful construct, the for each loop, and all it does is iterate through all the items in an array. So if we have an array with 5 elements and we say for each, the name of our array, which in this case is $A, and then we pick some name. So we picked just $item. It'll loop through every element in that array and set $item equal to that. So in this case, we'll print out current item 1, current item 2, 3, 4, and 5. Functions work just like they do in any other language. You have to go and declare them, and then you can call them. The syntax for this is function, the function name, and then in parentheses any variables you'd want. There's no variables in this example, but we could say do something, $A, comma, $B, and then whatever is inside of the function will get executed. The function has to be enclosed by curly braces. There's no header files, so you just have to make sure that your functions are defined before you call them. PHP, as it loads the file, will go and run it one line at a time. So if we were to just go and run this, the very first thing it would do is it would see the function, load that into memory, and then by the time we got to do something, since it's already in memory, it could go and actually run it. If we were to swap these two statements around and say do something before function do something, it would say that it doesn't know about the existence of the function do something. If you want to go and include other files, like I mentioned, this is a good way to go and keep your code organized. There's 4 functions available to you. There's include once, require, and require once. The once one, so include once and require once, will go and keep track of which files have already been read in and not allow them to be included a second time. So this is good to go and make sure you don't get into what's called an include loop. The only difference between include and require is that require will raise a fatal error if the file is not found, whereas include will just go and output a warning if warnings are enabled, but otherwise will allow your script to continue running. So in this case, for the example here, if we have 2 files, my other file and my other important file will both get loaded, but all 3 files exist. My other file, my other important file, and my third file. And so the very third one, or the 4th line, my third file, will not get loaded a second time because we're using require once rather than require, which would allow it to get included, even though it's already been included on the line right above it. Classes work exactly the same as they do in any other object-oriented language. By default, things are declared as private, so if you want them to be public, you have to say so. So here we create a class called myClass using the class keyword. We create a new value called 42. I've named it $_value just for convenience. You don't need to put the $sign there. You could just call it $value, and that will work just as well. And then I've created a setter and a getter. In this case, my getter prints it directly out to the browser, but normally you would want to go and return that to another function. So let me actually just go and update that to show you what proper convention is. You say $value or return $value. Or excuse me, $_value. There was a syntax error there before too. So if I were to say return $_value, that would go and return it to whoever had called my code. So, in this case, we're not actually doing anything with the return value, but if we wanted to, we could say $foo equals my class get value. Classes are instantiated using the new keyword, so my class equals new my class. The only difference here is the capital M versus the lowercase m, which is just convention. You don't have to do it that way. And then whenever you want to access something within a class, you use the right arrow operator. So my class, right arrow, get value, is how you invoke the get value function. You can also use this to go and access any properties such as $_value, which are public. If it's protected or private, of course you can't get to it. Some more on classes. You can go and create class methods or variables which are available outside of instances by prefixing them with static. This is basically the same way it works in C or in C++. Inheritance is available using the extends keyword. There's a constructor available, which is __construct, which will get called when a class gets instantiated. This is where you'd want to go and set up any properties that you're using. There's also a destructor available, but that's not commonly used because this is a garbage collected language, so there's no need to explicitly go and unset things. But if you do want to use it, it's __destruct. There's also a function called __call, which will get handed any function calls to non-existent functions. And so this allows you to basically go and make functions appear at runtime that wouldn't have existed otherwise. So this is actually a very powerful function. So in our previous example, we could have actually created some getters and setters that work across our entire class for any property, even if the getters and setters aren't explicitly defined. So that's just one of many tricks available to you as a developer. Getting HTML form data. HTML form data is always available in the $_post and $_get variables. They're globals actually. They're global variables. They're indexed by field name. Prior to PHP 4.1, these were named HTTP post vars and HTTP get vars. However, those are still available for legacy reasons. However, convention is to use _post and _get. So if we go and have a search box, most people normally go and use Q to go and indicate the name of their search field on their form. Like for example, Google does this. Since that's available as a get, the search field is being sent, or the search form is being sent using get. It's available in $_get Q. Post is available the same way. Basically, whatever you name your fields will be what the key will be for, what the field name. The field name will be the key in the array. There's also a third way, magic quotes, which is disabled by default. However, if you go into the PHP configuration and enable it, every field will automatically become a new variable. So in the above examples, we would have a variable named $Q, $first name, and $last name. However, this tends to be confusing and can become a bit of a security risk as a result. So convention is to leave it disabled. I recommend not using it. However, just in case you encounter that in the wild, this is what it is. If you're not familiar with HTML, just remember, or HTTP specifically, remember that get fields should never modify or delete data, especially since things like search engines will go through and hit all those links automatically. So if you, for example, have a link that uses get to delete some record in your database, and a search engine comes along, it has no problems going and visiting all those links and effectively delete all your data. So for that reason, if you're going to be modifying anything, be sure to use post and actually go and check and make sure that form that's being submitted is actually a post type form, and we'll go over that on the next slide, which is our hands-on demonstration on creating a mailer. So for people are worried about spam these days, maybe you want to have a contact form on your website to let people go and send you email without giving them your actual address. So that's what this little snippet of code does. Just like before, we go and say we have opening and closing PHP tags. The very first line, we go and see if the request method is equal to post. $server is an array that contains all of the variables given to PHP by the web server. Some of these change depending on which server you're using, so be sure to check that using the PHP info page we saw earlier. We go and set the sender and subject from the corresponding fields in the HTML form. We also set the message and word wrap it to 70 characters, set the to address, set a couple headers for convenience, so we're setting the from equal to an account that just exists on my web server, and then the reply to is the original sender's username, email address. And then mail is a function that's built into PHP that'll go and basically send off an email message. You can go and check what the contents of, or the format for the mail function by going to php.net/mail. So let's go ahead and take a look at this now. First thing, just to go and show you, we go to php.net/mail, and then we go down here. It's actually, since there's a chapter in the manual called mail, we actually want to go to the function called mail, and that's right there. And as you can see, here's all the various options that the mail function will accept as parameters. So let's go ahead and go to the server, create a brand new file called mailer.php. Open that up. Alright, just like before, we're going to start with some HTML. So let me go ahead and copy that in. So this is just basically, this is just an XHTML1 form, or an XHTML1 page. That's what this is up here. This is all just normal HTML. We're setting the title to be PHP mailer, and we create a brand new form. And we set the method equal to post as opposed to get. And we set from equal to the, from is just a input field. We give it the name from, and that's how PHP is going to know what this field is for. We did the same for subject, and we create a text area with the name message. And then we have our submit button so the user can go and submit all this. So let's save and take a look at it. So here's our basic form. Now, continue does absolutely nothing because we haven't told it to do anything. If you look at the source, it's just our form, nothing special. So let's add some PHP code into there. So this is exactly what's on the previous slide. The only difference is that I've gone and added a little field here called message sent. In this case, it's echo. Echo and print work exactly the same. They're synonyms for each other, so that's where that's coming from. And let's save this and take a look at the changes. So we reload our form. There we go. And as you can see, still nothing new. Now, let's see here. If we go and type in from me, subject, test message, we say hello world, and we say submit, it actually says that it sent the message. Now I'm not going to go ahead and open up my email right now because that'll take a little bit of time, but I assure you that this message, assuming the server is properly configured, which USC servers are, if you're using your own server, you have to actually go and verify that this is working, but at least on USC server, mail is set up correctly, so this has been sent to my email. And if I view the source, you still see none of that is actually in here. The only difference is, actually in this case it's not showing up. That's sort of strange. Anyway, this is probably because message sent, if I were to reload the page, doesn't actually appear. But the browser actually did receive P message sent right there. So now if we were to go and change our form and say it's a get form instead, reload the page, we'll even send our form data again. Oh, sending the form data, of course, we'll send it again, that's right. We have to reload the page, and now it's a get form. So as you can see right there, it's now type get from me. Subject test. This is a test message. Since it's a get form, all of this gets included in the URL, but since we're explicitly checking to make sure it's a post form, the message was not sent. Alright, so that's basically all that's going on in this demo. Let's go back to the slides. So frequently with PHP, you're going to want to go and work with the database. You do this using SQL, Structured Query Language. And it's a standard for interacting with relational databases, which is basically any type of database where you have a number of tables. Your rows in the table are each a record, and then your columns, by convention, are your fields. And then those fields can go and have relationships between each other, normally using the auto-generated IDs. So not all databases have exactly the same features available, so there's some differences even though SQL is a standard. But for the most part, so, these four common modes of operation all work the same. Select to go and perform queries on your data, insert to add new records, update to modify existing records, and then delete to remove existing records. So the syntax here, everything in yellow is the stuff that you won't be modifying, blue is your variables. Fields a list of table names. You can set this to star to mean any table. Fields is the list of field names. You can set it to star. So basically whatever is set for fields is the set of fields that will be returned for your data. I'll show you this in an example on the next slide. Tables is the list of tables to query. If you specify more than one table, it's going to go and merge them together. How the merging takes place I'll also show you on the next slide. Expression is how you go and specify the constraints for your search, and then count is just an upper limit on the number of records that will return in case you have 100,000 records in your database and you don't want all 100,000 of them. So the very first example, we're saying select star, so select all fields from the users table where the user's username is set equal to Bob. Alright? Second one, we're just requesting two specific fields. So if we have a subscribers table that maybe has a lot of information, but we really only want to know their first name and last name, we say select first name, last name from subscribers, and we set an upper limit of 50. And so that's the maximum number of records that can be returned. The very last one is to go and demonstrate how the merging takes place. This is called a join. I'm not going to go into the full details of how joins work. There's a couple different variants, but we're sort of limited on time, so I need to be ending here soon. So if we're here, we're selecting all fields from the students in the enrollments table. And in this case, enrollments just lists what classes a hypothetical student would be enrolled in. And so we're saying in the enrollment we have a field named student ID, and that student ID refers to the ID of a student. So we'd say students.id, the dot is how you go and specify a field. So students.id equals enrollment.studentID, and that'll go and make sure that those records are merged properly. And so in this case, if you have one student with 4 enrollments, you will go and get all 4 enrollments back. And so that's what we're doing with our next statement too, is we're constraining it to a specific student. So we're saying we only care about one particular student, the student with ID number 1, 2, 3, 4. Insert, the syntax is a little bit simpler. We say insert into table, in parentheses, we list the fields that we're going to specify, that we're inserting for that record, that we're specifying for that record, and then values is the actual list of data as a comma separated list. So here's a very simple example. We have a username. We're only setting the username, first name, and last name field. There might also be some other stuff, like, for example, a comments field or an auto-generated ID field is quite common, but we don't want to go and set either of those because the auto-generated ID is auto-generated, of course, and the comments we just don't care about. So we say username, first name, and last name, and then we specify all 3 of those. Username J Doe, first name John, last name Doe. Update is how you go and modify records. So table is the table that contains the record you're updating. The expression goes and tells it how to find that. Normally you just want to go and update one record, so you could just set an ID. But you could go and actually return, if your expression returns 10 or 20 records, it'll go and update all of them simultaneously. And how it does that update is what the key value pair does. This is just, for example, we could say, set the comments equals to, or if we have a comment field, we can go and set it to, last checked January 10th or something like that. And it'll go and apply it to all 10 records simultaneously. Count, like before, just places an upper limit on the number of records returned, which also sets a limit on how many can be updated. So for example, if you only want to affect one record to the max, you can say limit 1. And so even if your expression is really broad and would return every record in your database, this will at least constrain the damage and make sure that you don't change more than you intend. So here's a very simple example. We have a users table. We have a field named user_ID, and it could, let's say before it was set to 1000. Or no, let's say the user ID is 1234. I'm sorry. The user ID is 1234 for some user. Maybe their name was John, and we want to change their name to Bob. So that's what we're doing here. We just say find the user with ID 1234, and then set the field first name equal to Bob. All right. Delete works exactly the same way. You specify table. You give an expression. Everything that's returned by that will then be deleted, and then count specifies an upper bound. So here we delete user 1234 from the users table. All right. My PHP supports a number of databases. The most common one is MySQL, but there's also PostgreSQL and SQLite. SQLite's really nice when you don't have access to a full database available, especially during development, since it's entirely file-based and you don't need to go and install a separate database management program. And PHP supports all of these. It also supports a number of other ones, so you have quite a lot to choose from. There's 5 steps to go and use PHP with MySQL, and these are basically the same steps you'll perform for the other ones as well, though the function names change. You create a connection to the database using MySQL Connect. Pick a database using SelectDB. Give it a SQL statement, which is what we talked about on the previous slides, to execute. Check your results if desired. Obviously, for like a delete, you're not normally going to want to check that, though you can at least check and see how many rows were affected by your delete. Otherwise, you'll get a table back, and you can go and look through that table. And then when you're done, you close the connection and free it up for another process to use. So since we're running low on time, we don't actually go through this hands-on example, but I can just go ahead and summarize it for you very briefly. We're connecting to the server freesql.org with my username and my password as the username and password. We select the database, my database. In this case, we're working with a guest book, so we say let's get everything from the guest book, select star from guest book. And if we actually got a result back, so there's something there, we go and say for each record in the result table, so this is that for each operator again, we go and output the name of the person who left the record and the message. So an important thing to note here is that when you get the result is a table, each row in the table is represented as an array by it's basically a two-dimensional array. So result is an array of records, records is an array of field names, and PHP does this conversion automatically for you. And so here we're saying in the record get the field name and the field named message, and print all those out. If result is undefined, that means there's a database error, and we say so, and then finally we close the database. Some other topics, there's a number of libraries, PDO, and several other ones available too that go and provide an abstraction. So if you don't know what database you're using and you're packaging your script up, or you might think you might change databases later, this will go and let you, not rather than saying MySQL connect, you can, this a more generic thing, you're actually just saying connect to some database. There's a website called Pair that contains a lot of useful PHP libraries that you can drop into your code, and there's actually a command line pair program to download these as well. And then PHP has an extension called curl, which is really useful in accessing REST-based web services, which we talked about earlier in the week. Unfortunately, we don't have time to go over this either, but if you're curious, take a look on php.net, and there's more information on it there. All right. Attribution, parts of these slides were adapted from Dr. Michael Crowley's talk on PHP from last year, which is available for download from upe.usc.edu/pdf/php workshop. and you're welcome to distribute these slides under a Creative Commons attribution license if you please, or if you feel like doing it. All right. That's it. Thank you for watching, and we hope to see all of you on the programming contest this Sunday, February 17th, 2008. Thank you.